All right. Hello, everyone. Welcome to this What's New presentation for Fusion. We're going to give it about 30 to 60 seconds to let everyone in before we get started. Thanks for joining. And I believe as we're waiting, I put a comment in to welcome everyone. Let us know where you're watching from. And again, as we're waiting, when you add a comment to let us know where you're from or who you are, then you can also use that same comment area to ask questions throughout the webinar as well. Okay, great. I think we are probably ready to get started. Sound good, Kieran, James?
Sounds good.
Sounds great.
Okay. Well, once again, just want to thank everyone for joining us. This is the What's New presentation for Fusion. And so today we're going to be covering the enhancements for the November release. There's a lot of information to cover from what I hear from Kieran and James. James and Kieran are our experts in this webinar. James Kroniski is going to be covering design and engineering capabilities. And then Kieran Gill is going to take all things manufacturing. And so we're lucky to have them. Just a little bit about them. James is a mechanical engineer. He's based in Greenville, South Carolina. And he has a background in thermal design for high performance lighting fixtures. And today he serves as a senior technical marketing manager for Autodesk. James and I are on the same team. And he focuses a lot of his attention on Fusion and Inventor. And he uses his expertise on the product to talk to our customers. He's a great storyteller, and he does a great job with that. And it helps to understand the benefits of the products that you're using. And then Kieran is also a mechanical engineer by trade. And he graduated from in the UK from Oxford Brookes University. And he started his career also in the industry and specialized in manufacturing medical implants in the healthcare industries. And so here at Autodesk, he serves as a customer advocacy manager. And he focuses attention on 3 and 4 and 5-axis machining. He also spends a lot of time with customers, which helps to guide our development and ensure that what we put into Fusion continues to satisfy your needs. And so before I hand this off to them, I'm going to take 1 minute to make an announcement on the next slide. And so for those of you who are interested in taking a deep dive into data and process, there's a separate webinar coming for you. This is something that we could cover today, but we want to give it the attention that it deserves. And so this webinar is going to be coming around the beginning of the new year. So keep your eyes peeled for that. We're going to cover it in depth. I believe James is going to mention a few of the things that you might see here in this slide, just to give you a taste of what you're going to see with what's new in data and process. But again, watch out for that webinar coming soon. Okay, and that's it for me.
Yeah, actually, speaking of, I really wanted to shout out the delete while referenced. If my voice sounds mildly familiar, it's because I created the What's New YouTube video for Autodesk Fusion. The delete while referenced might be my favorite feature in this release, and it got a lot of attention on the YouTube video. So definitely go check that out. It's fantastic to have like a trash can that works how you would imagine, and I had a little fun with it. So let me know what y'all think. Alrighty. So next slide, if you don't mind. I just wanted to at least say on this release, the highlights are really in consumer product design, multi-axis machining, and the multidisciplinary collaboration. So there's quite a few updates that aren't going to make it in this presentation or didn't make it in the What's New video. The blog actually contains all of the release notes, and I highly recommend checking that out if there's some specifics. I know there's some updates in electronics, for instance, that we're not going to get to today that are fantastic and incredibly impactful for a lot of y'all using the electronics workspace. But I also just wanted to mention this as a theme more than anything. So you'll see updates in the design side, for instance, on things that help you consumer product designers out there. We really tried to make a focus of adding features that are relevant and are impactful for workflows for consumer products this time around. And speaking of, I just wanted to say this air fryer dataset made its debut maybe a year ago, but we had it on main stage at Autodesk University. We went ahead and took that time to improve it. We added a lot of detailing. We changed the PCB design. We even made a mold design for it, you might have seen. But I just wanted to put it up here as a flag of we've now uploaded that to the samples folder. So if you want to take a look at it, explore it, maybe critique it if you happen to be an air fryer manufacturer, we'd love to hear your comments. And those types of pieces of feedback really drive these features that we're developing. So let us know. Okay, so moving into my expertise, which is really on the design and documentation side. I try and leave Kieran to his manufacturing. I wanted to note something here on the intent-driven design, which I'm sure a lot of you have heard of from the Insider program. This is actually going into public preview later this week. So you'll be able to go into preferences and toggle this on. Everyone will. Later this week, there's going to be kind of a one-off update for some things on the data side, but we're going to include this as well. And this is actually a really fundamental change slash experiment slash an ask that we've had from the community. It's basically allowing you to start a part assembly or a hybrid design, which is more of what we imagine as the semi-traditional design style of Fusion. But we're trying this out. I will say it's going to come into full-blown release in some form probably at the beginning of next year sometime. But go check this out. Let us know what you think. And we're actively developing this. I think it's going to help a lot of users that switch between programs. Like I use Inventor a lot, and I'll sometimes pop into Fusion and I'll say, oh, wait, I didn't make an assembly design because I don't need to. It's just one of those things that if you're bouncing between CAD systems, or I know a lot of you use SolidWorks at work or Fusion at home or vice versa. It's one of those things that we're trying to make it easier to transition between. And also it's something that's highly requested and it's been incredibly well received. So all that rambling to say this is coming out later this year or later next year, and to check it out in public preview if you would like to try it out. Okay, so we're starting off with Sketch Auto Constrain. This has been out for a while now. It's one of the Autodesk AI tools that we know and love, but there's a huge update to it that we're sliding in here, and it's the ability for those sketches to actually be healed. It corrects them. So when you draw a sketch and it's not quite perfect, maybe you have a missing tangent or perpendicular constraint, or maybe there's a gap between the corner points of a sketch, there's a little sparkling icon that you can open up in the auto constrain menu and then actually just set it to fix your sketch. So it's like auto constrain gets auto fixing. And there's tolerances you can add if you don't want it to be, a certain degree of draft angles or something. You don't want it breaking all your draft angles and making them horizontal, vertical pieces. So definitely go check that out. It's really impactful for just speeding up your sketches. If you're like me, I kind of just sketch as I brain dump. So it's helpful to have something to go back and add all those constraints so downstream workflows don't get changed later. I didn't get to fit this one into the YouTube video, so I slid it in here. This is drawing limits and fits, which is amazing. It's pretty advanced for adding tolerances. So like H7 or G6, if you have that precise fitment. My favorite part about this, though, is actually way down the list. And it's almost like a formatter, kind of like the paint tool in PowerPoint or any Microsoft product, I think, where you can format the actual style of that annotation and then put it onto another. So it won't take the exact values like a copy paste, but it will take the formatting, the designations and such, and add all of that to the next one. So definitely check this out. It's really powerful, and I know a lot of folks have also been asking for this. It'll just make your whole documentation a lot more accurate and specific and reusable. this is another one that didn't quite make it into the video, but I love it. It's performance. So every release of Fusion, we make huge performance improvements, but we don't always get to showcase them off. But this one in particular is so impactful. It's about 97% compute improvements when doing complex sketches and patterns. There's also some editing dimensions tweaks on the back end of that. But the huge time is the compute time of most of those patterning commands. I pattern things all day long, so all of my sketches are atrocious. But I would highly recommend checking this out and let us know what you think. There's performance improvements in every single release of Fusion, and it's something we focus on constantly. But it's hard to make a flashy video for all of these performance improvements. So like I said, I just wanted to sneak it in here because it is really impressive how much they improved this one. Okay, center constraint. This was another one that it was at Autodesk University on main stage, live demoed. Not stressful at all. So these basically take two components and center align them when you're assembling it using the new centered constraint command. So you don't have to go in and create a mid-plane or anything and then snap those together. It's really smart as well. So even though this air fryer has draft angles and I think the body is like pretty rounded, it has all these kind of strange geometry features, Fusion figures that out for you. And so it'll slap together pretty much exactly what you would imagine. And then using the new constraint assembly experience, you can really just keep on adding until it's perfectly constrained all in one timeline command. I think we all like a tidy timeline, and this is a huge step into that. Asymmetric fillet. So speaking of consumer products, this is one that's been on the list for ages. This is basically exactly what it sounds like. You can create fillets now, kind of like how the chamfer tool has multiple dimensions. Your fillets can have multiple dimensions, and it gives you a ton of flexibility for how you can actually apply fillets to different edges or faces and what have you. The two different radii can obviously be found in the limit box. And there's also the concern, we kind of take this as a chance to fix some issues with like draft angles that pull on the fillets and such. It remains a really good parametric tool. And please let us know how y'all find this and what you're using it for. Actually, speaking of adding things in the chat, if you are creating some really cool consumer products and you're using this symmetric fillet, please let me know, because I've seen some really great examples and I know it's been out there on the to-do list for ages. So let me know what y'all are making. Rendering updates. We finally got some great rendering updates for Fusion this release, and I didn't get a chance to sneak it in. The rendering environment in Fusion doesn't get a lot of attention, so we're trying to change that with these next few releases. This is something that's very fundamental, but super helpful if you're doing renders. You can just move those components without needing to move back into the design space. So it's actually incredibly cool to be able to have your shadows and your lighting fall how you would expect. A pro tip somebody's told me, or perhaps James Mann, if you're listening, I think you told me, is to add a gap right between the ground plane and the object, and it makes the shadows beautiful now. So really great to see that. There were some other ground plane improvements that came along with this. So I'm not sure if that has anything to do with it, but that little tip has changed my rendering from very basic to quite advanced looking. Okay, decal updates. So decals are one of those things in Fusion you either use a ton of or you don't use it. And this is a update for y'all to start using decal updates in any way that you can, because the improvements are just fantastic this release. The sizing of the decals has been updated to a better interface. You can definitely restretch it to how you need. And I'll say that sometimes there was some issues with the pixel count coming in. So if you had it at 10 millimeter by 10 millimeter and you brought it in, it wouldn't come in that dimension. So we've resolved that. And if it doesn't for any reason, it can be stretched as needed. I will say there are some rounding anomalies that you should definitely check as well. And then the big update for this decal tool is that it now notifies you if you accidentally put your decal on the inner face. So it's easy to apply a decal, even though it appears oriented correctly, to basically the incorrect face. So if you go to render it or what have you, or create documentation, this is kind of a game breaker. So this update allows you to know exactly what face you're putting those on and convert it correctly. I'm sorry if I'm speeding through these. We had a lot of them, and I know Kieran has a bunch as well. So bounding solids. This is one of those that is great bridge between manufacturing and the design space, but you can quickly create those bounding boxes. It fully encloses your selected bodies, but also creates that timeline feature. So you can go back and do parametric changes. This is cylinder and rectangular prism basically now. It associatively updates, and it can be used in a set of objects as well as an individual one. So definitely give this a try. I know a lot of you have stock, which you can use this tool for, and that stock can also be edited with different features. So if you're fitting it into a vise or some type of machine specifically, you can add those features into that body as well. And I think that might be my last feature before I hand it over to Kieran. Sorry if I flew through that. Let me know if there's any other questions in the comments there.
Super duper. Thank you, James. Can everyone hear me okay? Super.
Yep, sounds great.
Great. So let's focus on manufacturing. We've got a lot to get through. I've actually got a few demonstrations I would like to walk you through in Fusion as well. So let's jump straight in. Now, the first one really for the November release is what we are calling a user coordinate system, or UCS. Now, the UCS is a general tool for defining coordinate systems in Fusion, particularly for horizontal end-to-end workflows using other workspaces as well as design. Now, the common application for this bit of technology is for 5-axis machining, where you may need to define a tool orientation and sketch a 2D toolpath boundary aligned with that tool orientation. Previously, this has been difficult, cumbersome, and problematic, but you can now use the design workspace to very easily create a user coordinate system and use the XY reference plane to create a sketch. Now, within the manufacturing workspace, you can consume that UCS to define any tool orientation and select the sketch to define the toolpath boundary. It's never been easier, and the video really gives you a really good idea of what that capability looks like, but also the power of that capability and what it brings going forward to the manufacturing environment. Okay, then on to trimming of visible selections. Now, part of the problem really when applying the trim modifications to toolpaths using a polygon, using the manufacturing extension, of course, meant that toolpaths themselves on the other side of a bit of geometry could often get caught by the cookie cutter effect. So you not only trim the area you want, but you also unknowingly trim the other portions of your toolpath, making for potentially dangerous cutting conditions. So not ideal. So with the November update, you can now choose to project the polygon onto the nearby surface instead of through the entire part. In this projection, only the visible selections of the toolpath within the polygon are considered to be quote unquote inside, and the rest of the toolpath is considered outside. This makes it far easier to make modifications more precisely and making changes where they are required more explicitly and avoiding changes elsewhere. All you simply need to do is check the visible areas only checkbox to make sure you are not trimming the wrong bits of your toolpath. Okay, then onto 3D toolpath containment. Now, have you ever kind of wondered why sometimes steep and shallow and corner would sometimes bleed outside of the boundary that you created? Well, to give you a bit of kind of context here, the real reason lies in how the toolpaths were consuming boundaries. Essentially, what's going on is that due to the nature of those toolpaths being born from PowerMill, they have always enjoyed the ability to consume 3D boundaries. Bringing that tech into Fusion meant that we had to essentially flatten the 3D boundary into a 2D boundary. This meant a less than ideal situation where the toolpath would sometimes essentially bleed out of that boundary, especially when you had steps in vertical orientations, for example, which 2D boundaries just didn't deal with as well. So that's all changed with the November release. And when using the steep and shallow or corner strategy now, the toolpath is now confined on vertical surfaces much more accurately when using the machining boundary selection as a contact point boundary. You will now also see that when checking the contact point boundary, that the boundary stays in 3D now and respects those vertical areas much more accurately. Ultimately, what does this all mean for customers and yourselves? It simply means there's less tool rollover on defined boundaries, more accurate toolpath containment, and just a much more accurate toolpath going forwards. Okay, so multi-axis drilling. This is a pretty big one. If you haven't already guessed it, we've added multi-axis capabilities to drilling operations, exposing the multi-axis tab with 3 new machining types to drilling. Those are polar, 4-axis, and 5-axis. So there's quite a lot to unpack here. So if you do want to take notes, feel free to do so. With respect to polar, what this does is it adds polar linking functionality to the drilling operations while maintaining cycle output for the cutting moves. This can enable you to stay within those machining limits where necessary. On 4-axis machining or 4-axis drilling, the controls allow you to define a rotary axis whereby the holes to be machined will generally be perpendicular to the axis or the rotational axis. You also have controls to specify whether the whole axis should intersect with the rotary axis. I don't know, for example, on holes on a cylinder, for example, or whether they can be shifted in the perpendicular plane. I don't know, a good example here as well would be holes on a cuboid shape around a rotary axis, for example. And additionally, there is also a control to specify a tilt angle, in which case the machine holes will be tilted away from the plane perpendicular to the rotary axis in a 4+1 fashion. Now, lastly, in 5-axis, the operation will machine the holes in full 5-axis, respecting the axis limits defined. You can apply a maximum as well as a minimum tilt angle with respect to a tool axis reference, as is common in other multi-axis milling strategies today, of course. And then kind of probably, look back at this, probably the kind of big call out here is that all toolpaths with machining types set to 4 and 5 axis will be output as expanded cycles in the post rather than canned cycles. And what this means is that there is no direct synchronization between the spindle and the feed rate. So ultimately, this means things like threading and tapping operations do not yet have multi-axis support. And I mean yet. Similarly, back boring does also not have multi-axis support yet either. Okay, so let's move on to machine over holes or pockets now, and we'll dive into a demonstration of this very shortly. Now, up until now, the ability to kind of machine over holes and pockets was only supported realistically by geodesic toolpaths and flat toolpaths through a tick box on the passes tab. Users have been able to get around that by creating capping surfaces and including them in their machine avoid selections for all other toolpaths. This functionality, as I mentioned, is supported currently in geodesic and flat, and we've now extended that to work for all 3D toolpaths that support machine avoid capabilities. Now, how you go about accessing this capability is slightly different depending on the toolpath you are using, so it's probably worth paying attention to this. For surface-driven based toolpaths, so I don't know, things like blend, flow, geodesic, the tick box can be found on the geometry tab in the geometry section. For all other toolpaths, it's found on the edit form of a surface group in the machine avoid surfaces table. So ultimately, slightly different access methods, so just something to be aware of there. Ticking the box, however, in both cases means that all surfaces in the surface group or the drive surface group will be automatically capped or untrimmed behind the scenes. And that means that any holes or pockets in these surfaces will automatically be machined over by the toolpath without the need for the user to go in and create extra additional capping surfaces downstream or upstream. So some real powerful workflows there to help you automate these toolpaths from ducking into those unnecessary holes. Okay, so with that, let's just stop sharing for a minute, and I will share Fusion for a minute. So I shall stop sharing and I'll reshare my screen. We'll just have a look at what that looks like in practice. So let me just grab the right screen here for everyone. And once can everyone see my Fusion screen at all? Yes. Okay, everyone can see the screen. Okay, so on the screen, we've got a simple part. Now, on the face of it, we've got two different toolpaths here. We've got a blend toolpath and a steep and shallow toolpath. Let's first look at the blend strategy. And let's kind of just have a closer look at this. Now, on the surface of this, it looks as if the toolpath is actually looking quite good. But if I kind of zoom in, you can actually see that the toolpath is ducking into that hole, creating unnecessarily tool engagement in potentially a lot of stock. This is potentially fatal for the tool, could damage the machine tool, and this is just something that we want to avoid. With the option turned on, you can see the toolpath just simply glides over that hole entirely. So for blend style toolpaths, which are surface derived toolpaths or surface driven toolpaths, the way you access the ability to machine over holes is to enable the machine over holes option within the geometry tab. Okay, so similarly, once that is activated, you can see the toolpath just simply avoids the hole. Let's now look at steep and shallow. Now, again, an undesirable effect here of the toolpath ducking into that hole. You can clearly see the kink of that toolpath ducking into that hole. So this is obviously something we want to avoid. And again, let's turn that functionality on, and you can clearly see with steep and shallow how it just simply glides over that hole. Now, with steep and shallow, this is slightly differently accessed to some of the other toolpaths. So for example, here in your machine avoid option, you can edit that machine avoid group. And within the actual faces that you are choosing to machine, you can enable the machine over holes functionality. So just to recap there, two different methods for invoking the machine over holes. For those toolpaths that are surface-based toolpaths like Blend, Flow, and Geodesic, you will access that from the Geometry tab. For other toolpaths, it is found on the surface group in the machine avoid table. Okay, so I will quickly stop sharing again, and we'll just very quickly just jump back into the presentation. So let's go over here. And let me know when you can see my screen. Right, so that is machine over pockets. And let's now jump into the whole template editor. Now, I kind of think this is pretty much a revelation in empowering you to automate your whole machining in Fusion going forwards. So you're probably thinking to yourself, but hang on, why is Autodesk introducing a whole template editor when we already have the ability to apply templates and we already have hole recognition? Well, there's a number of reasons, five big problems why we are introducing the whole template editor. The first problem really, and you'll have to bear with me as I kind of go on a rant here to kind of walk you through why we've done what we've done. First problem really is that hole recognition today has no concept of dimensional scrutiny for selecting a template. So imagine two countable holes, one very large and one very small. Hole recognition will recognize them both as a counterbore and show you all the templates that are associated to those counterbores. There's no concept of specifying templates based on the dimensions for any of those given features. The user still needs to hit the drop down and pick a template from the list. It's not very automated. The second problem really is that hole recognition templates only apply standard drilling to holes containing cylinders and cones. If that hole signature contains a fillet or even a groove ring for inserting, I don't know, something like an O-ring, for example, anywhere in that signature, you might as well throw all your hard-earned money into your nearest wishing well, because hole recognition sets the signature to ignore with no option to change it to anything else. Generally, to get around this, holes that have fillets or anything else other than a cylinder or cone, you could simply delete the fillet from the CAD, create a template for your hole, and then drill with a much smaller drill and come ramping down the hole to add in that fillet later with something like a bull or a bull nose. Talk about a nightmare. So that's the second problem. The third problem really is that most users will, generally speaking, import data from a third-party CAD software into Fusion as they transition over to Fusion. Now, the problem therein is that if it's a step file or a parasolid file, we lose all the hole data like hole type, thread info, and tolerances. Now, designers often communicate what type of hole it is and how it should be manufactured. So sometimes the designer will, in some circumstances, purposefully create holes with incorrect dimensions so that it can be purposefully identified as a cooling channel, maybe a water channel, maybe even a sprue bush hole, whatever. And now, a common way for designers to also convey their intent is through color. So color, in fact, in many companies and even industries, there are potentially rules to apply colors to some features and specifically to holes. So today with hole recognition, I might have two holes which look the same, might be dimensionally the same, might be dimensionally different. Difficult to tell, but they'll all be treated the same. And so the incorrect template is chosen for at least one of those holes. So the requirement really is to create a way to look at the hole dimensions, and the hole color, and determine what hole it is and how it should be machined. So that's problem number 3. The last two kind of problems are is that problem number 4 is hole recognition today contains the ability to apply templates and the idea that one can share those templates across the factory floor. Great in principle. You could share it across teams, across organizations, and it provides a nice comfort blanket so that the conformity of accuracy is achieved when drilling is standardized across the company. Sounds all good in practice. Generally, it'll be the drilling guy, the drilling maestro, the drilling guru that simply creates the templates and sends them to all of the colleagues. So today with hole recognition, when the colleague receives that file from the guru, all they have is a short name of that template. The template can't be looked at in any great detail. The template can't be opened to see what toolbars are inside that template, what settings are inside these toolbars, or what decisions were made to help create that template in the first place. The only thing a colleague can really do is generate some dummy toolbars from it and have a look at them. And essentially, users have been going on blind trust that the person who created the templates knew what they were doing. So call me cynical, call me glass half empty, but I'm not sure I trust that workflow myself. And then last but not least is problem number 5. So today, users will have a very specific tool diameter or a tool name in a template for general use and not specifically for a specific job use. Say, for example, they want to, I don't know, use a specific drilling tool diameter to match a specific threading process, like either a cut thread or a form thread. You just can't do that in hole recognition today. Hole recognition doesn't store tool diameters or tool names. It stores the tool as a percentage of the tool diameter. So a real good example is here. Let me think. Take two holes where you are machining a M6 or a M10, and you have two tapped holes essentially of differing sizes. So the current solution is going to give you an incorrect answer for, again, at least one of them, perhaps more likely incorrectly for both hole types, leading to suboptimal drilling or tapping and not what you wanted in the first place. So we need to be able to provide customers with a method of specifying a very specific tool or a very specific tool diameter for a specific hole type. So what I'd like to do now is to jump back to Fusion to show you the solution we have created in order to address these problems. Now, we will come back to the slide again, just to kind of recap on it all. So don't fear, we will come back. Okay, so let's jump into Fusion. Let me just stop sharing again and share my Fusion screen.
Hey, Kieran, if possible, can you share your entire screen? Because last time the dialog boxes didn't pop up when we were in the demo.
Right, no problem. let me do that for us. Share screen. And let's go entire screen, and let's go this one. And you just let me know, James, when you can see that okay.
Yeah, let's take a gander. Yep, we can see your whole screen. We can see Fusion in there.
Okay, brilliant. So sorry about that little technical issue, but hopefully the GIF in the previous image for the machine overhauls, machine over pockets highlighted the fact where you can see those two options in order to do machine overhauls for each of those different tools.
And those are also both included on the YouTube video and the blog post, which we went ahead and linked in the chat for folks if they want to review.
Brilliant. Okay, so on the screen, what we've got is we've got a whole bunch of holes on the screen. Now, I don't really know the depths of them. I don't really know the sizes of them. But what we're going to do is we're going to go into hole recognition. We're just going to see kind of what sort of holes we have given to us or being detected. Okay, so the first thing we're going to do is we'll move over this this little dialog box to the side. James, can you see the dialog box okay? Great. Okay, so we've got a whole bunch of kind of 3 millimeter holes, and you can clearly see that we'll zoom into it a little bit, but there is some color that's been denoted on some of these holes as well. So that could be denoting either kind of a water cooling channel, maybe kind of a sprue bush channel, just depends. We've got some 5, 6.8 millimeter holes and some more individual 6.8 millimeter holes. Now I'm just going to go ahead, just for the time being, to get some blank toolpaths on the screen. We're going to go ahead and select these two and just go ahead and get some simple drilling toolpaths on the screen, so we can start kind of playing around with our whole template editor. Okay, so once we have some toolpaths created, you can kind of see they're kind of spot drilled, and then subsequent increase in drill sizes. Now, let's kind of just zoom into the channels a little bit, and we'll kind of isolate this because they're effectively all the same all the way around. Now, what I could do is I could, in theory, to create a template today, I could individually highlight each of these toolbars, right-click and say, store as a whole template. But I'm not going to do that. What I'm going to do is I'm going to go to my template library, and within template library, I'm going to hit the plus option, and there are two new options called new whole template and new whole template from selection. And what I'm going to do is I'm going to now hover my mouse over some of the geometry on the part. And as you can see, well, yes, I can highlight some geometry around the part. And there you can see as I navigate. But as I kind of move over a bit of geometry that already has toolpaths associated to it, I can click that geometry. It highlights the toolpaths in the browser. I can click the green tick. And before we'll come back to this, importantly, what it does is it consumes the entirety of the whole signature into the template. I can see what segments highlighted not only in the table, but in the little 2D cross section on the right-hand side, get highlighted when you select them. But more importantly, it also imports the toolpaths associated to that particular whole signature. Okay, so let's jump back and let's just quickly fill this out. So let's go with something like my first whole template before we get a little bit more complicated. We can give this a simple description. But what we have the ability to do now is the ability to color whole geometries as well when they get identified by a particular template. Now for this, I've pulled in all of the correct geometry. I'm quite happy with that. I've got all of my toolpaths because we just created them from scratch. You could have your toolpaths already created. We're going to go ahead and save our first whole template. Okay, now I'm simply going to go ahead and delete. Simply go ahead and hit delete. And what we're going to do is we're going to go back into hole recognition. And we should, in theory, now see that some of the holes are automatically colored and detected as that pink color. Now, as we kind of look around the part, if we kind of look back at the part as a whole, we can see there are quite a number of hole geometries which we can equally machine with this template, and maybe prudent to machine with this template as well. So I can now go into my template editor. I can edit that template. And what we can start to begin to do is start to look to potentially loosen up this template to incorporate other hole geometries as well. So for example, I could now go to my height tab and say, right, what I'm looking for here is, for example, a range of heights from 10 to, for example, 20 millimeters. Now it's interesting because at this point, you don't really know what is going to be identified by the hole template or hole recognition going forward. But fortunately, there's a really nice tool here called the little eye or the preview matching holes. If you go ahead and select this, what it'll do is it'll kind of give you a preview of some of the holes it's already detected. Now, I haven't gone further enough. It's still picking up those original 8 holes. So hitting the X, we do need to loosen this up again. So again, I can come in and pick on my second bit of geometry in my signature. And let's pick, for example, a minimum height, and let's specify something like 8 millimeters, for example. Okay, now that we've got that, let's go ahead now and click on Save. And let's close that dialog box, and let's go ahead now and rerun hole recognition. So in theory now, what we should see is we should see all 32 holes now beautifully identified by that template that we created. Okay, so let's kind of have a look at those cooling channels again. You can kind of see there's those 32 holes that we identified, but the smaller of those cooling channels, we could use the template to do so, but it's probably not going to be efficient to do so. So what I'm going to go ahead and do is go ahead, take this original toolpath, and simply go ahead and duplicate that toolpath or that template. Double click on it, and let's go and call this, for example, my first small hole template, for example. Okay, again, we can leave those description and notes exactly the same, but let's go ahead and give this, I don't know, a cyan color, for example. Now, because we've duplicated it, it's using the geometry or the actual hole signature from the original bigger holes. So I can use this little select a hole from the model option to overwrite the hole geometry from the canvas with the new geometry. Additionally, I can now go into my toolpaths and say, actually, I don't need the 4mm drill anymore. I need to now open up the operation itself, and I need to go ahead and pick, for example, if I just bring that dialog across for you there, just open on the wrong screen. I can now go ahead, for example, and pick a much smaller drill. But there's much more intelligence built into this. I don't just need to specify a specific tool. I can use a search mechanism within the actual drilling dialog to choose either to get the best tool out of my entire library, whether that's selecting a specific diameter, whether that's a min-max diameter, whether that's a % of the tool to hole diameter ratio, whether that's a min-max to hole diameter ratio, whether that's a core drill or tap thread size tool as well. You have all the options to essentially tell the toolpath dialog to go and search through your entire tool library and pick the most appropriate tool given your constraints. Okay, so in this case, I'm just going to be very specific. I'm going to go ahead and, for example, pick the 2.4mm tool. Here it is. Got it. Pick it. And again, what we've done as well with all drilling toolpaths is provided collision detection and collision avoidance. So within flute, shaft, and holder, you can now automatically identify collisions and avoid them, as well as within the linking tab, have the ability to avoid collisions on all linking moves as well, should you want to do so. Okay, once you've selected the right tool, you can also go and rename operations as well. So for example, I know that this is now the 2.4mm drill instead of the 4mm drill. I can go ahead and change all the rest of them. I'm not going to do so. We're going to go ahead and click on OK. And when we go ahead now and run our hole recognition now, what we should see is we should see all 32 of those holes colored pink, but also our 5.38mm hole colored in cyan. Now, as we kind of look at these additional cooling 2.4 millimeter hole cooling holes or kind of sprue bush channel holes, it doesn't matter what they are. What you can see is there's three kind of key things here to be aware of. One is that we have a very specific color applied to a bit of hole geometry. And what we want the templates to do is really identify that color and use that color as an additional scrutinization method for essentially picking a template. So if it's red and it's the same size as every others, but it's red, then use this specific template. Again, we've got two other holes. Now, they may be the same size. They may be different sizes. One might be through into this slot. One might be blind. So we need to figure out quickly how to do this. And let me quickly show you how to do this. So the first thing we're going to do is let's just create quickly some dummy toolpaths. So we'll simply go into our toolpaths. We will simply ignore everything. We will pick out our red 2.4 millimeter hole. We'll simply drill and countersink it. Create two toolpaths for this. Once those toolpaths are created, I'm just going to simply go ahead and say store as a hole template. Okay, so the next thing we do is let's give it a quick name. So let's go for ahead and say 2.4 millimeter. Let's go. It's a blind hole. It is going to be an M3 tap, and it is going to be red. We'll give that the description. Again, because it's kind of a red color, let's equally again give it a red color as such. Now I'm going to kind of up the priority to something like 10, for example. And let's go quickly have a look at the signature. This is the important bit here. Notice how the signatures itself have consumed the colors from the actual signature of the hole itself from the CAD file. So that's really important to bear in mind. And then kind of our toolpaths have been created for us. So we can go ahead and save that toolpath now. Okay, and then what I'm going to do is I will just simply go ahead and delete my hole recognition again. Again, let's just go and double check this, go back into hole recognition, and we should see kind of 32 pink, a cyan, and a red color. Now, this is really easy to complete really essentially the last two, because what we can do now is go into our template library, and we can go to our red hole, and we can simply go ahead and duplicate that. What we're going to do now is let's just go ahead and say this is actually going to be a blind hole, but the signature itself now does not need to be additionally scrutinized with the red color. We can simply remove the red as well and call it a blind hole. And let's just change the color in this instance to something like orange, for example. And let's up our priority to something like 50. Okay, so in this case, what we should see now is, again, if we go into hole recognition, we should in theory see, a red colored hole for either a sprue bush or water channel of specific use. We should see our blind hole in orange. And last but not least, we should see, if we just duplicate this quickly, very quickly, let's just duplicate that because I know we are on time. And let's just, because we're in the habit of kind of stoplight or kind of traffic light colors, let's just call that a green color. And in this case, this is going to be a through hole to denote it goes through into that slot. We'll click on save, click close. And for example, in this case, we will just go ahead and highlight hole recognition, run hole recognition. And we should in theory see now that all of our, if I just click here, should see that we have all of our holes correctly identified, all associated with relevant templates, and our red, yellow, and green traffic light 2.4 millimeter cooling channel holes as well, correctly identified. So with that, let's jump straight back into the presentation just to finish off for 2 seconds, and then I'll hand you back over to James. Let's go there. and share. So let me know when you can see my screen finally. So that's the whole template editor in a very quick nutshell. Hopefully that was very useful for everyone to see that deep dive tutorial on that. And with that, that's all from the manufacturing side. I'll now hand you back over to James.
Thanks so much, Kieran. That was super informative for someone that doesn't spend much time in the manufacturing environment. Really cool updates there. I just wanted to put this slide back in the end just to kind of reiterate the overall goals of this release. So we really focus on the consumer product design side and multi-axis machining, and then multidisciplinary collaboration. A lot of the multidisciplinary collaboration updates, Jim mentioned it in the beginning. There's a webinar coming sometime in the very near future. I would have to double check, but definitely tune into that one as well, because that has a ton of those specific updates. Kieran and I really focused on the design and the manufacturing side for this webinar. And let's jump to the next slide.
Okay. So I'm going to give James and Kieran a little bit of time to look over the comments that have come through. There's a few questions in there. By the way, Kieran, it looks like it's getting a little bit darker over there. You're in the UK. Maybe, I don't know if that's the case for you.
Yes, but I'm a little bit far from the light switch to turn it on. So yes, it has become quite dark. So,
and it's good for everyone to know too, that you may have seen in the comments that those of you that are watching, you're across the globe. It's good to see everyone here. I see people in just about every country across the world. So it's really great to have everyone here. So once again, while they're taking a look at some of those questions, we'll get to those. One other quick slide here. There is a QR code for you. There's a bunch of things in here that you might be interested in. You can find out if how to start a free trial of Fusion if you haven't used it before. Maybe you're wondering about pricing for Fusion, or if there's any promotions available to save some money on your subscription. There's also a few testimonials in there from customers and FAQs for some of those common questions that come up. So I'll keep this slide up so that you can get your phone out and take a look at this link. And now I think we can take a look at a few of the questions that have come through.
Yeah, I have one question for the audience, and it is, let me look back here. I saw it pop up when y'all were talking about where you were from, and somebody said the Atlantic Ocean. Watching this webinar, I would absolutely love to know what you're doing. If you're on a sailing boat, 3D printing goosenecks or something, that would be the greatest story. So please let me know what you're actually doing in the Atlantic.
Yeah, I'll just clarify there. Yeah, it looks like I had some technical issues with the just with sharing the entire screen. So hopefully the GIF in the presentation showed it off quite nicely. For surface derived toolpaths, you will have the option to turn on machine over holes or pockets from the geometry tab. If you are not using a surface derived toolpath, like for example steep and shallow, you will be able to access that functionality from right clicking the model surfaces selection item within the machine avoid and turning on the checkbox within that. So just to clarify.
Let's see. So I'm looking through some of these questions that Jim had posted in our chat. So I'm liking the idea of intent-driven design in general. That's great to hear. Yeah, intent-driven design is something that you'll find in a lot of CAD programs. Like I said earlier, I just love switching from Inventor to Fusion and having that dialog box that feels a little bit more familiar. But I will say I have some beautiful, full-fledged hybrid designs that I've designed in Fusion that I wouldn't trade for the world. So it's really however y'all want to work. We're just trying to make it a little bit more apparent. You'll see when you do start those intent-driven designs, if you turn it on in public preview or when it's released in a few months or what have you. It's really about your UI more than anything else. So you'll just see changes to your UI if you're in an assembly design versus a part design. All this functionality has always been in Fusion. So we've always had kind of like internal and external or top-down, bottom-up designs. We're just trying to make it a little bit more accessible and logical. And we're taking the opportunity to do that so we can make some bigger improvements and performance and collaboration and those types of things. So let me know if you have any specific questions on that as well. Okay, there's a question here about variable radius fillets that change along chord length. I can definitely submit that. If you're a part of the Insider program, I would recommend submitting it there because that pretty much is a beeline to the developers. I will say one thing I didn't mention is asymmetric fillet obviously works with configurations. So we've seen some really cool ones where folks have made, configurations from the parameters within asymmetrical fillet, and you can get a lot of flexibility there.
I'm just going through all the names, and it's just so good to see so many of the people I know. I've visited a lot of the customers on this call. I can see. It's good to see everyone here. Thanks for attending.
Yeah, a lot of these questions are for me, it seems.
James, I don't know if you mentioned the question about the recording, but obviously it is being recorded and can be watched later. For any of you that may be interested in the deck, that's something that's not typically available. If you are a partner, an Autodesk partner, then that's something that we perhaps we can look into and get this over to you.
Okay, there's a question here about adding the ability to use dual dimensions, such as just any imperial or metric on their drawings. I believe that's already in Fusion. You can just go to your document settings and add a secondary unit or additional unit. And so you could have inches and millimeters, for instance. If you're thinking about something slightly different and more specific, feel free to reach out and let me know what you're trying to do. But I believe that functionality is already in there, just in document settings in your drawings. Let's see, this is more of a suggestion. Using the name of a construction. Oh, I'm sorry, seeing the name of the construction plane somewhere on the screen. Yeah, so you're imagining, are you using SolidWorks now, perhaps? I believe Inventor also has this, where you'll see XY plane on the XY plane. It's a really good idea. I think, especially when you start to have a bunch of construction planes, having plane 6 or plane 6, no, seriously, plane 6, it'd be nice to have it correctly labeled and have that appear. That's a very good suggestion. Thank you. Question here, going to add a feature for sharing sheet metal bend libraries across multiple seats without having to make a model and adding each one to your personal library. Trying to remember. So I will say there was a, if you join the Insider program, or if you're a part of the Insider program, definitely take a look. There was a webinar just very similar to this with a bunch of updates. And I would say go ahead and look at that. Join the Insider program. I can't talk too much about those features in this format. I would also love to know what you're doing. If you're sharing across multiple seats and you have a library set up for sheet metal, I would love to just talk to you about what exactly you're creating and make sure that we tailor your needs to what you want there.
Yeah, regarding the 4K video, yeah, I mean, that's an interesting one. That's something for Randy and some of the marketing team to kind of look to address.
Oh,
sure.
upgrading.
But do you for sure.
Do you want 4K video of the presentation or of Kieran and I's beautiful faces? Because those would be two different requests. If you're having trouble seeing the screen, we can definitely double check the play resolution that we do. Getting Kieran and I some nice cameras, though, would be a bonus.
I wonder if it's the YouTube settings, because by default it's auto, right? But you could change it to 1080. I wonder if that makes a difference down in the settings.
4K is great, but I will say it makes a lot of our file sizes quite unmanageable, but we could definitely look into it more if that's a request.
Yeah, I don't recommend seeing me in 4K.
I was pretty surprised when they wanted to see us even more clearly.
James, it looks like Randy put a link, or maybe you put the link in there to the Insider program.
Oh,
Which is
yes.
good.
So the Insider program, I've mentioned it a few times. Just to reiterate, Insider program is free. You just join it to see some of these features early, at least a few months. It also gives us the opportunity to have direct conversations with y'all as far as, you know, what features you're looking for, your sentiment towards features. Perhaps you don't like a dialogue popping up or not. A lot of the features that you saw in this release actually came directly from the Insider program. So intent-driven design is huge, obviously. But simple things, even like the render, I want a dialog box telling me when I put my decal on the inside of a face rather than the outside. Those types of things, we don't get to play around with the software as much as Kieran and I would love to just play in Fusion all day or design things. It's really helpful to have a wide range of customers giving us advice and tidbits. So please look into joining the Insider. Like I said, it's free, and there's a whole community that you'll be plugged into. Let's see.
We are at the top of the hour. So what we could do is answer the questions as they come in. We could still answer them I believe we can still put them in the comment box. Is that right?
Yeah, I can definitely answer a couple more. We are at time though. I'm sorry, I'm not sure I'm following this question. Nick, can you create a multi-layer architecture for simulation more than CFD? That seems like a pretty complex. I mean, I came from industry using CFD, and I would do similar thermal simulations as what I do in Fusion on a regular basis. Biochemistry or biochemical engineering with complex fluid dynamics, you'd really have to play with the settings. I would need to know more about the scale you're working on. You can do a lot of the same functionality. That one's a pretty specific one. You might need to send me some more information on. Yeah, I think that's all we probably have time for. I think I've got most all of them, so I'm free to wrap up whenever, Jim.
Yeah, like I said, we'll try to get back to you on some of these. For example, Nick, you've got some questions on CFD. I love CFD, so we might be able to get some answers there. But for now, we are past the top of the hour, so we're going to wrap things up. Thank you again, James and Kieran, for presenting today. For everyone who's on the call, if you saw something that you like, or something that's going to make your life a little bit easier each day, then again, click on the like button, share this video out. Once again, stay tuned for a data and process webinar. James mentioned that earlier too, probably the beginning of the year. And so thank you everyone again for being here. Have a great day.
Thanks, y'all.